some problems which are stated just in the same is very elementary about a set of family of subsets resist solutions which are combinatorial themselves, and often, let's say, even without using any heavy mathematics, require just the use of linear algebra. But require in the sense that we don't seem to have other methods to solve them. To what extent do you believe that using combinatorial methods or elementary methods for elementary problems in general is sufficient?
No, it's not sufficient. You just mentioned some in computer science when it's the problem itself really of a combinatorial nature, but the solution requires at least linear algebra, and this is beautiful. It works like magic, and without it they cannot solve. And then in number theory there are many problems where actually in arithmetic combinatorics, which are combinatorial nature, but we know then the solution requires either higher order Fourier analysis or ergodic theory, and then they get stronger and stronger results. So I am a strong believer, though it works against me, that yes, for solving combinatorial problems you will need more and more to borrow tools and even ideas from different branch of mathematics, but that actually makes the combinatorial problem more interesting and say even deeper. Yes, and then the solution requires interplay between different branch of mathematics. That is what really is the thing which makes the problem very and the solution very interesting. And then usually what happens, and once you do it for one thing, then most probably then you can apply the same ideas, not exactly but similar, to solve some other problems, actually problems which are seemingly far from your original combinatorial problems. You are theoretical computer scientist, so you know this phenomenon very well, that this happens more often than not. And I am very happy for that. Unfortunately, unhappy that I don't know these tools, but actually I decided to study mathematics now. I am not joking, it's a very serious thing that my original plan was to go back and what I missed at that time, because I didn't start as a mathematician, and even the first 2 years was for physics and mathematics. And for some strange reason, even after that, the professors were not at home at that time, rainy, to some over abroad, so we didn't get a real good education. And once you are 25, you don't get good education. You have to be or very devoted to mathematics and hardworking, or you just give it up and then work on a problem. So I am unfortunately belong to the second group, but I always felt a need. But to feel a need to study and actually study is unfortunately two different things. But now I really started to study things which I wanted 50 years ago. Well, it's a very slow process. I feel that I have been slowing down considerably, though my interest is more intense than it was 50 years ago. That is a strange contradiction. But you need for combinatorics, even if I want to solve a problem in combinatorics, and I would like.
But you know which tools you think you will need in order to solve them?
Well, I guess, yes, I guess. So now I am studying harmonic analysis, but on the elementary level, I really, if somebody told me then in Budapest, I spend most of the time in Budapest now, that there is a class on this subject that then I would sit in. Though most probably my color of my hair would make it a little bit strange sitting and then of course to color it's just too much price for the knowledge.
It's hard to know what to use, even if you are, even if it's definitely within your range of tools.